In this video, we're going to look at the Unit 2B review for pre-calculus. The number one just asks us to look at factoring these different polynomials. So in part A, since we have a trinomial that only has an a value of 1, you can just look for the factors of 16 that add to the middle number of 8. And so we want to look for factors of 16. So they multiply to 18 and they add to 8, and that's going to be 4 and 4. So then this will just factor to x plus 4 times x plus 4. You could also write this as x plus 4 squared if you wanted to. Either one of those is fine. Part B is the same story. It has the a value of 1, so we just want to look for the factors of 70, positive 70 that add to negative 17. So that's going to be negative 10 and negative 7. So then this will factor to x minus 10 and x minus 7. Part C is again a trinomial, but this time all of the terms have an x in common. So we're going to take out one of the x's first. So we're going to distribute out an x. So x cubed take out an x would give us x squared. 3x squared take out an x would give us 3x. And 2x take out an x would give us 2. Then we can go ahead and divide that leftover trinomial here, or factor this leftover trinomial. So again, it has an a value of 1. So we can take the factors of the last number 2 that add to the middle number. So this is just going to be 2 and 1. So we have this x on the outside, and then this trinomial will factor to x plus 2 and then x plus 1. Part D gives us an a value that is not 1, okay? So this a value is 3. So now we actually need to multiply those two terms together. So you're going to need to multiply these together, and you get 18x squared. And then you want to find the factors of that add to this 11 in the middle. So the factors of 18 that add to 11 are 9x and 2x. So then you can put this in the box so that you can factor it. And we'll put our original polynomial down the middle diagonal here. So we have the 3x squared, we have the 11x, and we have the 6. And then we're going to plug in these two factors that we found into the boxes on the other diagonal. It does not matter which diagonal you put them in, or sorry, which box you put them in. Then you're going to take out a common factor along the top. So what's in common between 9x and 3x squared? So they both have a factor of 3. And they also both have a factor of x. Then I like to just fill in the rest of the blanks. So now 3x times this top one will equal 3x squared. So 3x times x multiplies to that 3x squared. Then x times this number will give us 2x. So x times 2. And then 3x times this number should give us this 9x. So 3x times 3 gives us 9x. And then I always check the final box. 3 times 2 equals 6. So then our factors are x plus 3 from the top and 3x plus 2 from the side. Part E, same story. It's got an a value that's not 1. So we can multiply the 3 and the negative 9 together to get negative 27x squared. And then find the factors of negative 27 that add to negative 26. So since it's a negative product, we're going to have one of each number, positive and negative. So negative 27x times 1x will give us negative 27x squared. And then if we add those, it gets us the negative 26 in the middle there. So then we can put this in the box again. So our polynomial will go along this diagonal. And then we will plug in these factors that we got into the other two boxes. And then you're going to take out common factors. Okay, I like to start on the top. So both of negative 27x and 3x squared divide by 3, and they divide by x. And then 3x times x gives us this 3x squared. 3x times negative 9 gives us the negative 27x. And then x times 1 gives us 1x. And then checking that final box, 1 times negative 9 gives us negative 9. So that means everything is working out. So then x minus 9 times 3x plus 1 is the factored version. And then in part F, this is a binomial, and we can see that they both have an x in them. So we can take an x factor out. So x squared factor out in x is x. 3x factor out in x is 3. And then that can't factor any further. So that would be finished. The next problems are asking you to solve the rational functions. And in this case, they're proportions on both sides. So it's just one fraction equal to another fraction. So you can cross multiply for this. I'm just going to use the least common denominator since that's what we've been working on others. But so we could multiply here. We see this 5 on the bottom. So we need to multiply it. And we see the 6 on the bottom. So we need to multiply by both of those. So we're going to multiply it in. So I'm just going to write down this original portion here. Now make sure you get parentheses around this now that you're multiplying, because you're going to want to make sure you multiply the whole expression by the numbers that we're multiplying here. So I'm just going to get a parenthesis around this one too. And then we're going to multiply this 5 and 6 into both of these. So we're going to multiply times 5 and times 6 in that one, times 5 and times 6 in this one. So then you can see that the 5s cancel, and you can see that the 6s cancel here. So then we just need to distribute what's left. So we're going to distribute the 6 in here and here. So we're going to get 6x minus 36 on the left side. And then over here, the 6 is canceled. So now we need to multiply the 5 with the x plus 1. So that's going to be 5x plus 5. Then we'll just solve for x here. And so we can get the x's together on the same side by subtracting 5x from both sides. So 6x minus 5x is 1x. Minus 36 equals 5. So then we'll add 36 to both sides. And we end up with x equals 41. Now, there's no extraneous solutions possible here since our bottom numbers can't ever be 0 because they're 5 and 6. So there's no variables down there. So 41 is our answer. Then in this next one, we will multiply by those bottom numbers again. So we'll multiply by x plus 2. And then we also want to multiply by x plus 4. So again, I'll just write down this original polynomial so we can kind of see the canceling happen. Now we're not going to multiply anything in the bottom, so I'm not going to put parentheses around that in the denominator. You can if you want to. But we are going to multiply both of these factors over here and over here. So we're going to multiply 3 times x plus 2 and times x minus 4. And we're going to multiply the 5 times x plus 2 and x plus 4. I don't know why I said minus over here. This should be a plus. Okay, then we can cross out common factors. So we see that the x plus 2 is a factor in the denominator and the numerator. So we'll cancel that out. and we see that the x plus 4 is a factor in the denominator and the numerator on the right side. So we'll cancel that out. So then, and I'm just going to write this out before I distribute. So then we're left with 3 times x plus 4 on the left, and we're left with 5 times x plus 2 on the right. Then you're going to want to distribute here. So you get 3x plus 12, and then distribute the 5. So you get 5x plus 10. Then you want to solve. So we'll get the x's together. So we'll just subtract 3x from both sides. So we get 12 is equal to 2x plus 10. Then you can subtract 10 from both sides, and you get 2 equals 2x. Divide by 2 on both sides, and you get x equals 1. Now that we had variables in the denominator, now we need to check that this doesn't make either of these 0. And it doesn't, because 1 plus 2 is 3, not 0. And 1 plus 4 is 5, not 0. So x equals 1 is a good solution. Next one, we see that we have 3 terms now instead of just 2. So you couldn't do cross multiplication on this. Okay, but we can do what I was doing where we're multiplying by the least common denominator. Now remember, the 4 has a denominator of a 1. So the only factor in the denominator right now is really x plus 5. So we're going to multiply everything times x plus 5. So let me just get this written out. So these are our original, this is our original equation, and then I'm just going to distribute this x plus 5 into all of them. So we're going to multiply this one times x plus 5, this one times x plus 5, and this one times x plus 5. So then we see that this x plus 5 cancels in the first one, and we're just left with x. And then we have nothing cancel in the second one, so we're left with 4 times x plus 5. And then in this last one, the x plus 5 cancels, and we're left with negative 5. So then we will be able to distribute here this 4. So we end up with 4x plus 20 equals negative 5. We can combine these like terms. And then we want to solve. So we'll subtract the 20 from both sides. So we're left with 5x equals negative 25. And then we can divide by 5. And we get x equals negative 5. So then we need to go back to the original problem, and we need to see if negative 5 is a good solution. And so when we plug it into the denominator here, negative 5 plus 5 gives us 0, which is bad. We can't have division by 0. So this is an extraneous solution. So that means there's no solutions to this problem, since the solution that we got mathematically ended up giving us division by 0, and there's no other options. Okay, then next one, we would want to factor this denominator first. So we want to look for the factors of 6 that add to 5, and that would be 2 and 3. So this is going to factor to x plus 2, x plus 3. And then we're going to want to multiply by the least common denominator to cancel out these denominators. So we're going to want to multiply by x plus 2 and x plus 3. Okay, that's what we had here and here. And now we've already accounted for the x plus 2, and we've already accounted for the x plus 3. So we're just going to multiply by those. So then I'm going to write this first part down, or I'm going to write my original equation down here. Okay, so then I'm going to go ahead and multiply the x plus 2 and x plus 3 into all pieces. Okay, so x plus 2, x plus 3, x plus 2, x plus 3, and we're going to multiply the x plus 2 and the x plus 3 onto that one as well. So then we see that this x plus 2 factor will cancel. So we're left with x times x plus 3 for that one. Then in this next one, the x plus 3 will cancel with the x plus 3. So we're left with 2 times x plus 2 on the top. And then over here, the x plus 2 will cancel and the x plus 3 will cancel. And we're left with the 3x plus 7. So then we'll distribute and we'll get x squared plus 3x. And then we'll distribute the 2 to get 2x plus 4. And then we have this 3x plus 7. So now we can combine these like terms. And we have x squared plus 5x plus 4 equals 3x plus 7. So now we have a quadratic. We have an x squared term and an x. So we're not going to be able to isolate the variable on one side and the numbers on the other. So we're going to want to bring everything over to one side. So we're going to want to subtract this 3x over, and we're going to want to subtract this 7 over. So we get x squared plus 2x minus 3 equals 0. And now we're going to factor this quadratic. Okay, it has an a value of 1. So we can just look for the factors of -3 that add to 2. And that's going to be +3 and -1. So 3 times -1 is the -3. 3x and -1x gives us that 2x. And then we would just set these both equal to 0 and solve. So we can subtract 3 from both sides and we can add 1 to both sides. So these are our two possible solutions, -3 and 1. So we're going to go back up. Okay, and we got x equals 3 and x equals -1. And neither of those make the denominator 0 because 3 plus 2 is 5. 3 plus 3 is 6. -1 plus 2 is 1. -1 plus 3 is 2. So neither of them are extraneous. So they're both good solutions. Number 6 asks us to find the slant asymptote of this function. So remember, we know it's a slant because the degree on top is higher than the degree on bottom. And we find the slant asymptote by doing long division and ignoring the remainder. So we're going to divide by the x plus 2 factor. So we can put 2x squared here from that polynomial, so right here. So x times 2x gives us 2x squared. So then we can figure out this bottom box here by doing 2x times 2, which is 4x. Then this blank and this blank have to add to what we had in our polynomial of 1x. So 4x plus -3x would get us to 1x. Then we can figure out what this number is. Okay, because this times x gives us -3x. So x times -3 gives us that -3x. And then you can stop because you're down to your constant. So the rest of it's just going to get you your remainder, which we're going to ignore anyways. Okay, but if you did, you'd get -6. And then -6 plus the remainder has to get us to -3. So then our remainder would be 3. But you're just going to ignore this stuff anyways because this is your slant asymptote. Okay, y equals 2x minus 3. Number 7 is asking us to graph this. So we're going to go through looking at an analysis of it first, and then we will graph it. So first thing, I would factor that top piece so that we can look for any the x-intercepts, holes, vertical asymptotes come from the bottom, but if there was a factor on the top, it would be a hole. So the factors of -4 that add to -3 are -4 and +1. So we have this. And so this would be, I guess this is in this first part. This is our factor and simplify. Okay, so here's our factored form. Now, there's no common factors, right? Because we have an x minus 4 and an x plus 4. So those are not the same. Find any horizontal or slant asymptotes. So remember, this is where you compare the degree on top and the degree on bottom. So I would look at your original function here, okay? So we've got a 2 and a 1 before we actually factored them. So the top is bigger than the bottom. This means it's going to be a slant asymptote. So just like we just did in the last problem, we're going to do long division here to figure this out. And so we're going to divide by x plus 4. We had an x squared in here. So x times x gave us x squared. X times 4 gives us 4x. 4x plus this next box needs to equal -3x. Okay, so this needs to be -7. So that 4 minus 7 is that -3. Then x times -7 gives us the -7x. And we can stop because we don't care about the remainder for slant asymptotes. So our slant asymptote here is y equals x minus 7. Vertical asymptotes, remember, are where only the bottom equals 0. Okay, and so that's going to come from this x plus 4 factor equaling 0. So x plus 4 equals 0, so we would subtract 4, and we get x equals -4 for our vertical asymptote. And I'm just going to plot that onto the graph right away. So x equals -4 is our vertical asymptote. X-intercepts are where the top only equals 0. Okay, so top only equals 0. So we see those. We see two factors up here that are unique to the top. Okay, so then x minus 4 equals 0 would give us 4. X plus 1 equals 0 would give us -1. So those are our two x-intercepts, okay, at -1 and at 4. Y-intercepts, you plug x equals 0 into your function. And I would go to this, you can go to either, but it's easiest in my opinion in the multiplied out version, because then you're doing 0 squared, which is 0, -3 times 0, which is 0, and then you have the -4. And then on the bottom, you have 0 plus 4. So then you get -4 over 4, which gives you -1. So your y-intercept is at -1. Then you'll want to see, okay, so when it says, does the function contain a hole? And a hole would be if the top and bottom are the same, and we do not have any factors that are the same. So we're going to say no hole here. Then it wants you to just do a sketch of the graph. So remember, we haven't put on our slant asymptote yet. So let's go ahead and do that. Now this one has a y-intercept of -7, which is actually off our graph. It's down here, right? So let me plug in a different x value to find this. So I'm going to plug in 2. And 2 minus 7 is -5. So I do know that this point is on there. I could also plug in 1. 1 minus 7 is -6. Okay, and then 3 minus 7 is -4. So then you can kind of see the slope happening there. So the up 1 over 1. So that gives us our slant asymptote. So let me just get that in there. And so this one might, you're really not getting a very good picture on this graph of the function because it's actually going to keep going down here. So let me extend this and just show you. So if we like extended this vertical asymptote and we extended this horizontal asymptote, if we had a bigger graph, okay, you would have the branch that you can see in here because of all of the points that we know, okay? So it would be going towards this vertical. Whoops. Let me move that. Hang on. Let me move this graph back to where it was supposed to be. So this was 1 and -1. Okay. So then you've got, these branches are going to go towards here. They're going to come through and they're going to hit this, and then they're going to go back out towards this. And you can graph this in your calculator. Just make sure you get parentheses around the top and the bottom, and you can get actual points to plot. And then there's going to be this other branch down here that we're not going to be plotting on ours because our graph wasn't big enough. But that's what it looks like on a zoomed out level. All right, then number 8. So then this one, you'll want to factor the denominator first. So again, we have an a value of 1, so we can just find the factors of -15 that add to +2. So we do 5 and 3, and we want the 5 to be positive and the 3 to be negative. So it adds to that +2 there. So then find the horizontal or the slant asymptote. So now your top degree is less than your bottom degree. So remember, that's automatically y equals 0. And so we can get the y equals 0 horizontal in there right away. Vertical asymptotes make only the denominator 0. And so we see that we have 2 of those. So we have x equals -5 for that first one, and x equals 3 for the second one. So those are our 2 vertical asymptotes. Okay, so then you can just plot those right away. And then the x-intercepts make the top only 0. Okay, so we can see that x plus 3 up here. So -3 for our x-intercept. So if we go to -3 and we plot it there, and then the y-intercept, you plug 0 in. So I'm going to go back to this original. So I'm going to do 0 plus 3 on the top. And then we'd have 0 plus 0 minus 15 on the bottom. So we would have 3 over 15, which simplifies to 1 over 5 if we divide both of them by 3, which is 0.2. So it's like just really close here, okay, to the y-axis or to the x-axis. And then does this contain a hole? And we do not see a factor in both the top and bottom. So this one does not contain a hole. And so then you're going to want to sketch this. And so you'll probably want to put this in your calculator. So make sure you put parentheses. I would do this one. Okay. And I would make sure you get parentheses around the top and the bottom. So go ahead and type that into your calculator. And when you do that, you could go in to the table. So if you hit second table, you could check that. And now I'm seeing, hold on, right here, I have this as 15 and it should be -15. So this should have been -0.2. So I missed that negative. So it was a -15 on the bottom. So that should have been -0.2. But you can hit second table, and that will, or second graph, really, the button is labeled graph, and that'll end up getting you a table so you can plot some points, or you can just sketch the branches when you look at the window. So if you're not super precise, that's fine. I just want you to go through the x-intercept and the y-intercept. So that one kind of went like this. The other branch was down here. Okay, and then you had a branch here. So if you just want to kind of sketch those in, that's fine. If you want to go into second graph and plot some of the points that it says to make it super precise, you could do that as well.